How is it going, everyone? So I've created a new site called oswald.build where it'll have lessons and these interactive simulations on these different topics where you can try out and kind of play around with simulation to understand the topic a little bit more. So let me know what you think about that. But I'll be using this as a guide through this video to explain what idempotency is. So tiny summary. Retries and crashes are unavoidable in distributed systems, and idempotency is a way that systems can survive them in a smooth fashion. So what is idempotency? So as I mentioned, distributed systems, which are just systems that communicate over the network. So pretty much every system nowadays is distributed. So you have your cell phone connecting to your social media app. That's a distributed system because you're communicating over a network. So networks are unreliable. So, they do have failures from time to time, even though you might not notice them, but you've probably noticed them in the past. So there's a number of issues that happen in distributed systems with networks and other things, right? So networks can fail, like your request can just drop, timeouts happen, servers crash, and then responses could get lost. So let's say you submit a API request, it actually goes through on the other end, but somehow maybe your server gets crashed, or you lose the response somehow. So then you have no record that the request actually went through. And just quick everyday life examples here. So when things fail, typically the first thing we do is do a retry. So daily examples of retries: we start a car, turn the key. If it doesn't work, you retry it. Sending a text, if it says it's not delivered, we resend it. Refreshing a browser, we do this quite a bit when the internet's slow or the site is slow. We just keep retrying. And this is good, right? Typically, retries help us get to our end result. But there's kind of two categories of retries, right? There's things that are safe to retry, and then there's things that are not safe to retry. So some things that are safe to retry are like reads, like we want to read what our bank account balance is. If we, read it multiple times, that's definitely safe. We're not mutating anything on the other end. Looking up an order status, checking the weather over and over again, which I do constantly. These are safe to retry, obviously. And the things that are not safe to retry, if I charge a credit card and I don't know if it actually went through or not, it might not be safe to retry that, right? If I sent an email, but I'm not sure if it actually went through, should I resend it? It might be awkward if I send 2 emails to someone. Things with, money involved, right? With flights or hotels, should I try to rebook a flight and rebook a hotel if I'm not sure if the first request actually went through? So these are things that are not safe to retry, and this is where idempotency comes in. So idempotency is doing something once has the same effect as doing it multiple times. So it makes retries safe. Okay, so let me just reiterate that. Idempotency is doing something once has the same effect as doing it multiple times. So it makes retries safe. So the key thing is to implement systems that produce side effects. So as a software engineer, as you're designing systems, let's say you're designing a system that is a credit card system. You want to implement idempotency so that your side affecting credit card service, things that are not safe to retry, you want to implement those in an idempotent way, which means doing something once has the same thing as doing it multiple times. So if you get a request to book a credit card for John Doe for the same amount, the same request, multiple times, you don't want to double charge them. All right, and there's 2 different flows of idempotency here. I probably won't go through all of these. I'll just quickly touch on this. So there's inbound consumer idempotency. So that is the case where I am receiving requests. So the example I just did, maybe I'm a credit card system clients are calling me, I want to implement a way for them to pass an idempotency key. This is a key that uniquely identifies this message. So if it's John Doe for amount $10 and they want to charge their credit card, I need them to pass an idempotency key, which would be a unique identifier, string probably, that identifies that request uniquely. So then on the server, I can look up in my database or cache if I have seen that key before, if I've already processed that request. Without that, I don't know if that request is unique or a duplicate or if I've seen it before. So then you'll implement an idempotency key on the request. You'll check if the idempotency key is there. Then I'll just return the previous response because that is a request that already came. However, if the idempotency key lookup is a miss, then I will actually do the side effecting call, so charging the credit card. And then I'll return the regular response, and then I'll store that idempotency key, so in case it comes again in the future, if the client does a retry or something, then I won't double charge. Okay, so that is the basic flow. Okay, and then there's the producer flow, which is kind of you're the client sending to the API server. So you need to make sure you send the idempotency key and check if the API that you're calling supports this. Not all the APIs do. I have not documented what to do in that case if the API server does not support idempotency keys. So there's other things that you can do on your end, but it's a little more complicated. This tutorial is just kind of the basics of idempotency and what to be aware of. So same thing here. You send the idempotency key. It processes the side effect if the idempotency key is not found, and then it comes back. Okay, I think these two diagrams are kind of the same. I'm just realizing. But just kind of two different ways of looking at the problem, but they're pretty much the same. Okay, so let's look at the simulation here. So I've simulated what idempotency could mean with an idempotency key and then not having idempotency. So let's just change the request to 2 requests for now, and then I'm not going to pass an idempotency key. So that means I could get duplicate requests. Okay, so I hit send, and this is just kind of doing an interactive kind of visual representation of that sequence diagram I had earlier. So the client, and this is kind of a flight booking simulation. So our client sends a request to the API server, which is the flight booking server, and it's brand new, so it saves it, and then that flight is booked. That one's happy case. That worked great. Another request came in to book a flight to LAX. It's new and it saves it, but let's say the response here is lost. Somehow the client, the client crashed or something happened with the network. This response that this flight got booked is lost somehow. So then a retry happens, right? Because the client thinks that that didn't happen. So they retry this LAX flight booking. And because I'm not using an idempotency key, no idempotency key came through, the new request is then saved again, which means that we've now double booked the request, and now we have a duplicate booked. Even though the client thinks it's just one, when they look at their credit card and their email, they'll probably see that 2 flights were now booked for the exact same customer, which is a big problem, right? All right, so now let's enable an idempotency key. So it's send request again. All right, this one, kind of every time you run this, it's going to be a little bit different scenario because it uses like basically a calculation here. 30% of the time, there's going to be a response lost. It looks like this one happened for both of the requests, which is fine. So New York City, it came through, and this purple line is the new line that does an extra check on that idempotency key that came in, okay, because we've enabled idempotency key. So we check the key, it's new, and it saves, but let's say the response is lost again. Okay, same thing here, LAX, check key, it's new, response is lost. Okay, so what the client's going to do is retry those previously sent requests because it didn't get a response. It got lost. But they actually got saved or processed here, right? So New York City comes in, they check the key, and then the key does exist in the DB, so we're preventing a duplicate here, and then we return a previous response. Okay, so that means we did not actually charge the customer double because we checked and that request already came through. So now we return that previous response. LAX comes in, same thing, we check the key, it exists, so we're going to prevent that duplicate request being made or flight being booked, and then we'll return the previous response here. Okay, so then in summary, all unique, no duplicates, 2 flights were booked as they were supposed to. And then there is an event log here. So hopefully that gives you an idea of what idempotency could do. All right, so that is a pretty simplistic example, but hopefully it gives you a good intro into what idempotency is and how it can help in your distributed systems design and implementation. Let me know if you have any questions. Thanks.